Okay, this is picking up from the notes that we were in on Thursday's class. Going back, and there was one question we skipped over a part. This was example 3, I believe, part C from the 6.3 packet. It wanted us to find all the trig values associated with pi over 2. Now, the big thing is figuring out where pi over 2 is. That's always the first step. So if you think about it, pi over 2 is 90 degrees, because if you're not sure about that, you can always multiply it by the 180 over pi. Notice the pi's cancel, and 180 divided by 2 is 90, so it's 90 degrees. We're going to arbitrarily pick a point on this terminal side. The easiest point to pick is always the one that includes the 1. So this is 0, 1. That means it has a radius of 1 if you think about the length of this segment. So now we should have all of our trig functions. So sine of pi over 2, cosine of pi over 2, and tangent of pi over 2. And we should also have cosecant of pi over 2, secant, and cotangent. So remember, sine is opposite, which is the y value, over the hypotenuse, which is the radius. So that would be opposite, or excuse me, y would be 1, and radius would also be 1. So this is just 1 over 1, or 1, which means cosecant is also 1 over 1, which is 1. Cosine would be the x over r. So that would be 0 over 1, which is 1. Or excuse me, 0, sorry. That means that when you flip this, this is 1 over 0. So secant would be undefined. And then tangent is y over x, which is 1 over 0, which is undefined. And we flip that, that's 0 over 1, which is just 0. So notice there's this matching of whatever 0 is for 1, the reciprocal is always the undefined, and vice versa. Okay, so now we're going back to graphing sine, cosine, and tangent. This is something we talked about when we graphed. Actually, I'm going to regraph all of the functions. We kind of went through some of them in class together in detail, and then we looked at some of them on Desmos. Remember I told you to write that down. It's a really great graphing website. It'll help you get through a lot of things if you have to take higher level math. So we learned that sine repeats its pattern on 2 pi. So that means that is its period. Cosine is also going to repeat on 2 pi, but we're going to learn that tangent is only going to repeat every pi, so 180 degrees instead of 360. Now we're going to make the graphs of each of these. I'm going to redo sine, like I said, because we were at the end of class. So I've got some graphs here. These should be on your notes if you printed them out. If not, you'll need to make your own. So what are we going to write about sine? Y equals sine x. But remember what I told you, x is really like our theta, and y is like the sine value of the ordered pair on the unit circle, okay, which we worked on in class. Okay, so we made a little XY chart where this is really our theta, or our angle, and this is really our sine value at that angle. Okay, so I started out with 0 because that's one of the easiest angles to plug in or to figure out. Just to make life a little easier, we're just going to go up by pi over 4 each time. So pi over 4, if you add another pi over 4, that'd be 2 pi over 4, which is pi over a half. Then we have 3 pi over 4. Then we would have 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2. Then we would have 7 pi over 4, and 8 pi over 4 is 2 pi. Now, if it helps, remember, think of the unit circle that goes along with this. So remember, we're just thinking about a unit circle, and as the angles get larger, because remember this is 0, pi over 2, pi, and 3 pi over 2. So those other guys are 45-degree angles because they're halfway between each of these. So like this is 7 pi over 4. This is 5 pi over 4, 3 pi over 4, and this one was just pi over 4. And all we're going to be doing is thinking about what sine value goes with each of these. That means what is the y-coordinate at that ordered pair on the unit circle. So if you think of sine of 0, we said, well, this is the ordered pair 1, 0. So sine's value is 0 there because it's the y-coordinate. Pi over 4 was square root of 2 over 2 and square root of 2 over 2 because we learned that when we did our unit circle, so the y value is square root of 2 over 2. At pi over 2 you have the ordered pair 0, 1, so the y value is 1. At 3 pi over 4 you have the exact same point mirrored from the first quadrant, except now your x is negative, but your y is still positive, so that is still square root of 2 over 2. At pi, your ordered pair is negative 1, 0, so you would have 0 for the y value. At 5 pi over 4, you would have negative square root of 2 over 2 and negative square root of 2 over 2 because you're still a 45-degree angle, but you're in quadrant 3, so everything's negative. And 3 pi over 2 is 0, negative 1, so the y value is negative 1. And 7 pi over 4 is a positive x, but a negative y. So it's a negative square root of 2 over 2, and 2 pi is in the same place as 0, so the answer is the same. It's still 0. So now when we plot this, we had this, I'm just going to give myself a rough estimate. Let's call this fourth line up 1, and the bottom line 4 down, negative 1. That gives us kind of a fractional split we could use. And then we're going to label our, like say, every other mark just to give us some distance. This would be pi over 4. This would be pi over 2. 3 pi over 4. Pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And 2 pi. Now we did say that this pattern continues, so just because I'm not drawing those individual pieces, we can estimate where they're going to be just by the pattern repeating. And you could just click extra ordered pairs or negative radians to prove it. So 0, 0, square root of 2 divided by 2, we estimated that in class, but let's do it again. So 2, take a square root, and then divide by 2. That gives you 0.7. So if you think of this as 1/4, 1/2, 3/4, 3/4 is 75%, so you're a little bit lower than that. Make sure that point sticks. And then pi over 2 is at 1. And then 3 pi is down at the square root of 2 over 2 again. And then pi is 0. 5 pi over 4 is negative square root of 2 over 2. 3 pi over 2 is negative 1. And 7 pi over 4 is negative square root of 2 over 2. And 2 pi is at 0. So notice we get this curve up to positive 1, back down to 0 at pi, down to negative 1. That's a bad curve. At 3 pi over 2, and then back up to 0 at 2 pi. Now, of course, this pattern is going to continue, which is hard to draw it from here. So this took 1, 2 to get out to there, so 1, 2 down back to negative 1, 1, 2 back to 0, just kind of giving it a rough sketch of the same pattern. So this is our sine function and things that we know about it. Domain, There's no gaps in this graph on the x-axis. Notice every x has a point somewhere. So that means it's negative infinity to infinity. And our range is -1 up to +1, everything in between there. And something else we didn't talk about. This is a function that has some symmetry, but the symmetry is origin symmetry here. Or actually, sorry, not origin symmetry. We'll talk about the symmetry in a minute, so we'll come back to that. Okay. Sorry, got sidetracked. I'm actually going to leave my unit circle there because this helps me with my cosine function. So here we're doing cosine of x. Need to make another little table of values. So xy, we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. I'm going to do a separate chart over here just so I don't have to write too far down. Pick up with 5 pi over 4, 6 pi over 4, which is 3 pi over 2 when you reduce it, and 7 pi over 4, and 8 pi over 4 is 2 pi. Okay, this time we're looking at cosine. Cosine is the x values of all of these ordered pairs. So at 0, the x value is actually 1. At pi over 4, it's square root of 2 over 2. At pi over 2, it's 0. At 3 pi over 4, it's negative square root of 2 over 2. At pi, the x value is -1. At 5 pi over 4, it's negative square root of 2 over 2. At 3 pi over 2, the x value is 0. At 7 pi over 4, the x value is the square root of 2 over 2. That little square root erased for some reason. And back at 2 pi, we're back to 1. So notice this is just offset. The same pattern is repeating as before. It's just starting differently. So if we have this marked as our 1, here's our -1. Here is our pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. We start at 1. We go down to square root of 2 over 2. We go down to 0 at pi over 2. At 3 pi over 4, we're down at negative square root of 2 over 2. At pi, we're down at -1. 5 pi over 4, we're at negative square root of 2 over 2 again. 3 pi over, 2, we're at 0. 7 pi over 4, we're at square root of 2 over 2. And at 2 pi, we're back up at +1. So notice this has the similar pattern of going from high, +1, down through 0, up back to -1, and then back up to 1. This one will continue this pattern in the same way that we saw before, just kind of roughly sketching it out. I know that's a bad sketch, but it continues the same pattern as the other one did. So things that we know. It repeats every 2 pi, that's its period. It has a domain of -infinity to infinity. Any x or theta we want to plug in has a value for it. Range is still -1 to 1. Now, so that's sine and cosine. The part of the graph of the sine and cosine functions corresponding from 0 to 2 pi is one cycle. We sometimes refer to it as cycle as the sine wave or the cosine wave. The range of the sine cosine functions consists of all the real numbers between -1 and 1. Since cosecant is the reciprocal of sine and secant is the reciprocal of cosine, it'll follow that the range of cosecant and secant are actually greater than 1 and -1. So you'll have that their domains, or excuse me, their range will be -infinity to -1. union with 1 to infinity. In other words, their range will be the opposite of this interval. So as we shall see, the range of tangent and cotangent will also consist of all real numbers, but they are going to have domain issues. So before discussing graphs of the other trig functions, let's talk about something. And in fact, I'm going to stop this video. This is formulas for negative because I can only post a 15-minute video at a time. So this is going to be part 1, and there'll be a second video for part 2.